Good morning. My name is Dr. Mallikarjun. I am working in Institute of Aeronautical Engineering, Department of Information Technology. So, in the series of video lectures of operating systems, today I am going to give the complete explanation of preemptive scheduling, and we will work out one problem. So, preemptive scheduling is in operating system allows the operating system interrupt a currently a running process. The process is running, that process can interrupt by other process with their priority. Means that highest priority process is execute fast, then execute the next priority of the process. So the priority having, suppose the priority levels 1, 2, 3, suppose these are the priority levels, the highest priority here 3. So then first give the chance of the highest priority process for the execution. Then the next priority goes to this 2, priority 2. Then priority 2 process is execute the next. Then it goes to the next level of the priority 1. That process is going to execute the next. Means that it process of in the operating system to interrupt a currently running process and switch to another process, usually based on priority or a time slice. Based on a time slice, that process can switch to another process in the execution scenario. Usually based on priority or a time slice is ensured that no single process monopolizes the CPU and allows for better responsiveness and fairness. So it gives the of the process how priority of the NAS, it gives the next process of the fairness. Especially in a multitasking environment and scheduling to another process, it keeps on switching for the executing and give the process of the chance. It goes to the give to next process. In the real time environment of the situation, we will see the how the in real time scenarios how preemptive process is executing. We will see with one example. Let me go to check one problem, and we worked out that problem based on the priority level, how the process is executing. We will see one problem. Students, please see this problem. This problem comes given the priorities. There are 7 process. Process 1, 2, 3, 4, 5, 6, 7 process are given. These 7 process, their priorities are given. Their priorities are 2, 4, 6, 10, 8, 12, 9, their priorities. Their arrival times are given. Their burst times are given. To execute the process as for the priority here, the first give the chance to the here priority of the process. First give the chance to the priority. The highest priority we observed here, 12 gives the process has the highest priority. Okay, let me see the Gantt chart, how the process are executing in the Gantt chart. Means that process submit to CPU as per the Gantt chart and the process are executing as per the scenario. Let me see the Gantt chart here. At zeroth arrival of time, first process P1 enter into the CPU and executing for 1 unit of time. Then at one arrival time, process P2 is entered and execute 1 unit of time. Now arrival time is 2. Now second arrival time, process P3 enters and execute 1 unit of time. Means here 1 unit of time is completed, remaining 3 units of time is left. And P2 completed 1 unit of time, remaining 1 unit of time is left. P3 completed because arrival time up to 5. So we will take up to 5, arrival time 5, up to 5 arrival time. Let me take. So it has completed, not be 5. Let me take again 1 unit of time, it will execute. So it is 3 units of time. So it is remaining time is left, 2 units of time is left. So at the time 3 units of time, so arrival time 3, so P4 enter into CPU and execute up to 5 units of time. Up to 5 units of time it will execute. So at the time of fifth unit of time, which process is going to be executed next? That is the very important point we will notice here. So after 50 unit of time, arrival time 5 units, the highest priority is the 12. Highest priority is 12. So that 50 unit of time, P6 enter into CPU and execute P6. P6 will execute that their bus time, P6 bus time is 4 units of time. P6 bus time is 4 units of time. It will complete up to 9 units of time. So up to 9 units of time, entire P6 is completed because it is the highest priority of the process. So it will execute completely, so that their burst time becomes 0. It completed the entire execution up to 9 P6. Burst time becomes 0. Now P6 completed the execution. Then which is the highest priority? So all processes are arrived up to 9 units of time. All processes arrived. Which got the highest priority? P6. So of P6 is the 12 priority of the process 12. Then which is the next priority of the process? The next priority of the process is going to 10 units of time. After 12 units of time, the next priority is going to the 10 units of time. Then P4 is submit to the CPU in the Gantt chart. P4 it execute completely. P4 burst time is 5 units. So it's completed the execute 5 units of the burst time completely execute. So it become 14 units of time. P4 is completed. Process P4 is completed because their priority is 10. So that's why P4 is submit to CPU and executed completely. So next priority we will see the after 10 priority we will see the next priority. Next priority of the process is P9. The priority is 9. That process is P7. That process is P7. Actually, P4 is executed here. That is 2 units of time is left. Then it is executed. P4 executed. That is 2 units of time left. 2 units of time it executed. So that it is not 3 units of time. It become left is 3 units of time here. That 3 units of time is executed here. It not become 14. It become is 12 units of time. It is 12 units of time. Now P4 is completed here. P4 is completed. Then we will see the next priority of the chances. So which is the next priority of the process P4? After P4, the priority goes to P7. P7. So P7 comes, execute into the CPU, P7. So their bus time is 6. So up to 18 units of time, P7 comes and execute in the CPU. So, it become 0 of P7 become 0. P7 become P7 bus time become 0. Then which is the next process after P7? After P7, we observe that the priority, we observe that 9 is completed. Then we observe that priority 5. So P5 comes and execute their bus time up to 1 unit of time. It will go to 19. So it is completed, it becomes 0. So the priority is completed here. 8 process priority completed entirely, it become 19. We will see that after 8, the priority 6 then goes to the next priority is 6. Then P3 comes and starts for the execution. Then P3 comes and starts for the execution. Their bus time is 2 units of time. So up to 21 units of time, P3 is execute. Up to 21 of time, P3 will execute. So it becomes 0. So P3 is the 4 that becomes 0. Then P1 and P2 are there remaining. All processes are completed their execution. Then P1 and P2 is only there. So in from the P1 and P2, then P2 got the highest priority. So that will execute fast P2. P2 got the highest priority. That will execute fast. That is 1 unit of time. So 22, it will complete P2. 22 complete P2. So P2 becomes 0. Up to 22 units of time, P2 is completed. Then only one process is left. That is P1. So that P1 bus time is 3 units of time. So that is 22 plus 3, 25. Up to 25, P1 is also completed. So as per the priority is the main role here in the scheduling process. In the Gantt chart, as per the priority, the process are executing one by one. So as the process are executing one by one as per the priority, the process is switched to the next process. That priority is the performing the main role. One process is completed, then it gives the next process, it can switch. After that process, it can give the next process as per the priority is the main role here. So we calculated their burst times. Then we will calculate the completion time of the process. So let me check the completion time when P1 is completed at 25 minutes of time. P2 is completed at 22 units of time. P3 is completed at 21 units of time. P4 is completed at 12 units of time. P5 is completed at 19 units of time. P5. P6 is completed at 9 units of time. P6 is completed. P7 is completed at 18 units of time. P7 is completed. So their completion times we notice it here. The process which their completed times we mentioned here. Then we calculate the turnaround time, that is completion time minus arrival time. We calculate the turnaround time. Now completion time 25, the arrival time 0. That is the turnaround time for P1 is 25. Now P2 completion time 22, their arrival time 1. That is 21 is the turnaround time for P2. P3 completion time 21, their arrival time 2. That is 19, 20, 21. 19 is the turnaround time for P3. Then P4 completion time is 12. The arrival time is 3. 12 minus 3, that is 9. 9 is the turnaround time for P4. P5 completion time is 19. That arrival time is 4. So 19 minus 4, 15 is the turnaround time for P5. P6 completed time is 9. That arrival time is 4. 9 minus 5 is 4 is the turnaround time for P6. So P7 completion time is 18, then arrival time is 6, that 18 minus 6, 12 is the 12 units of time is the turnaround time for P7. Now we calculate the waiting time. So waiting time is calculated as per the turnaround time minus burst time. So we subtracted as per the timing units of the turnaround times and burst times, we will get the waiting times. So turnaround time minus burst times. So burst time is 4 for burst time 4 is P1. So 4 is subtracted from the turnaround time 25. 25 minus 4, that is 21 is the waiting time for P1. So P2 turnaround time is 21, that burst time is 2, that is subtracted 21 minus 2, that is 19 is the waiting time for the P2. P3 turnaround time is 19, their burst time is 3, so 19 minus 3, 16 is the turnaround waiting time for P3. P4 turnaround time is 9, their burst time is 5, so 9 minus 5 is 4 is for P4. P5 turnaround time is 15, their burst time is 1, so 15 minus 1 is the 14 is the waiting time for P5. P6 turnaround time is 4, their burst time is 4, so waiting time is turnaround time minus burst time, it becomes 0 for the P6. 7 turnaround time is 12, that burst time is 6, so turnaround time is 12, the burst time is 6, 12 minus 6 is the waiting time for P7. So now we calculated all waiting times. Then we calculated the response time. It's a very important factor here in the priority scheduling. We calculated as the response time. Response time here, the process when it enter into CPU, that you can subtract from that time into the the process in the arrival time. So P1 arrived at 0 and their arrival time is 0. So response time for P1 is 0. P2 arrival time 1, their response time arrived at 1, 1 minus 1, 0. P3 2, the response time arrival time is also 2, that is also 0 P3. P4 at received from the Gantt chart is 3 units of time. P4 is 3 units of time. P4 arrival time is also 3, 3 minus 3 is also 0 for P4. Similarly, P4, P5, we observe that P5 once entered into the Gantt chart at 18 units of time, P5 arrived at 4. So 18 minus 4, that is 14 is the response time for P5. P6, when it arrived in the Gantt chart 5, P6 is 5, P6 arrival time 5, P6 becomes 0. So P7 is the last process that arrived in the Gantt chart for P7 is the 12 units of time. P7 arrival time is 6. So 12 minus 6, 6 is the response time. So we calculated all response times, all waiting times, all turnaround times and completion times individually as per the priority based scheduling. Next we simply calculated as average waiting time. We calculate all waiting times divided by total 7 process. We will get the average waiting time and calculate the average turnaround time, that we calculated sum of all turnaround times by total number of process 7. Then we calculated as the average turnaround time. Similarly, we calculated response time, average response time, all response times 14 plus 6, that is 20 by 7. So 20 by 7 almost 2.8 something. So almost 3. Almost average response time approximately 3 units of time. we calculated as the response time for average response time for each process. So we worked out this problem. With this problem completely based on the priority of the process. As per the priority of the process, the process once received and it execute the next, it decides by the priority. Means that the highest priority process is execute fast, then it gives the next priority of the process, execute the next. Based on that priority order, the processor keeps on executing in the CPU. So let me discuss completely that priority process completely as per the preemptive scheduling. That is a very important point. Notice that priorities preemptive scheduling is a priority based scheduling. That is a priority. See, let the operating system can interrupt or preempt a running process, allocate CPU to another process, typically based on priority or time sharing policies. Mainly, a process is switched from the running state to a ready state. Once process switching keeps on switching are more in algorithm based on preemptive scheduling. It's based on round robin scheduling, shortest remaining time scheduling, and priority scheduling based on the preemptive version. So priority scheduling and preemptive scheduling both are same, almost similar. See, non-preemptive is different nature. A running process cannot be interrupted. Once the process submit to CPU, it completely execute that process that can switch to the next process voluntarily, relinquish and control from the CPU. It's switch the next process and execute in the CPU. This scheduling, once the resource CPU cycle it allocated a one process, it can switch to give to another process. The process holds CPU till it gets terminated or the process going to reach a waiting state. Algorithms are based on non-preemptive schedulings are first come first serve, shortest job first. These are non-preemptive nature. Priority is a non-preemptive version also there and preemptive version also there. Okay, we calculated every factor of units of time, arrival time. This is a different for process scheduling algorithms one by one. The process scheduling algorithms first come first serve is different, shortest job first is different, round robin is different. So all arrival time should be the fixed one for every scheduling algorithm. The burst time of the process for once it fixed it, notice it that this is the burst time is fixed for this scheduling algorithm. This burst time is fixed for this scheduling algorithms. That preemptive nature, the burst time keeps on changing the while process executing. While in non-preemptive nature, the burst time is there, that is completely becomes zero. Then it goes to the next process in the execution line. So completion time, once process finish its execution in the Gantt chart, it notices that that time is a completion time unit factor. Waiting time is the process spends the amount of time in the CPU for waiting time. That waiting time we calculated as completion time minus arrival time. We calculate as the waiting time. In similarly, turnaround time, the total time from arrival to completion, that is noticed that turnaround time. We simply calculated turnaround time is a waiting time minus burst time. We simply calculate the turnaround time. A response time is the delay before the process receive its first to submit to CPU. That we noticed that is a response time. Okay, students, I give an entire brief explanation of the preemptive scheduling as per the priority processing, priority based scheduling. So preemptive nature comes from the priority based scheduling algorithm. So these concepts are more, and this procedure is given detailed explanation in the books Abraham Hilbert Scratch B. Galvin book, George Ganji book. The title of the book, Operating System Principles, Wiley Study Student Edition, Publishers, 8th edition, 2010. And also the book, William Stallings, title of the book, Operating Systems, Internals and Design Principles. This publisher is Pearson Education, publisher, 6th edition, 2002. Preemptive scheduling based on working in the priority nature. Okay, students, thank you for watching this video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.